Welcome everyone. The question that is shown on the screen, it is a CBSE sample paper 2025. Question number 5. A capacitor consists two parallel plates with an area of cross section 0.001 meter square separated by a distance of 0.001 meter. If the voltage across the plate varies at the rate of 10 to the power 8 volt per second, then the value of the displacement current through the capacitor is, four options are given: 8.85 into 10 to the power minus 3 ampere, 8.85 into 10 to the minus 3 amperes, 7.85 into 10 to the power minus 3 ampere, and 9.85 into 10 to the power minus 3 ampere. So these options are given here. So this is the questions from the electromagnetic wave. I hope you understood. So there at the starting we have learned four Maxwell equations. Okay, four Maxwell equations. Among them, one of the equation is that is the del cross E equal to minus del V del T in the differential form. So here it is somehow says that the changing magnetic field results in the electric field. Okay, electric field and magnetic field are not the independent phenomena, they are dependent phenomena. Changing magnetic field creates electric field. So obviously natural law of symmetry, so changing electric field should create the magnetic field. So for that purpose, Maxwell has taken Ampere's law, B dot dl equal to mu naught I enclosed. Maxwell has said this law is incomplete. We have to add one quantity here, which is the displacement current, and this displacement current is defined as epsilon naught d phi dt. Here phi means phi electric field. Okay, that means the electric flux. So it will be epsilon naught d dt of integration of E dot ds. So if the surface is obviously a complete one, enclosed one, then this sign should be here. Now you tell me where you have seen this equation, cyclic integral E dot ds. You have seen this equation as you have read this equation as a Gauss's law, cyclic integral E dot ds equal to q enclosed divided by epsilon naught, that is a Gauss's law. So epsilon naught is a constant that can be taken outside the integration and it can be cancelled out. Okay, so this will become d dt of q enclosed. Okay, and we also know this, that is a q equal to cv. Okay, so this thing can be written as d dt of c into v. Okay, so since c is constant, so it is dv dt. Okay, since c is constant, it is the dv dt. Clear? So obviously from here two parallel plates are kept, their cross sectional areas are given, capital A is given, the distance between them is given. So what is the expression of the capacitance? The expression of the capacitance is epsilon naught capital A divided by D. Okay, epsilon naught is 8.854 multiplied by 10 to the power minus 12. The area is 0.001 divided by distance is 0.0001. Okay, so obviously it is 8.854 multiplied by 10 to the power minus 12. this can be written as 10 to the power minus 3 and this can be written as 10 to the power minus 4. So this will become, obviously this will become minus 1, so 10 will be multiplied. So that will be 8.854 multiplied by 10 to the power minus 11 farad. That is the capacitance. We have just found it out the expression of the displacement current, that is the ID, that is C dV dt. C is 8.854 into 10 to the power minus 11. Now dV dt. See, if the voltage across the plate varies 10 to the power 8 volt per second, 10 to the power 8 volt per second, that is dV dt, that is 10 to the power 8 volt per second. So if I place it here 10 to the power 8, so this will become 8.854 into 10 to the power minus 3 and that thing in ampere. So option A is the correct option here. Thank you all of you.